And thank you for having me, everybody. So I hope everybody's getting used to Zoom calls, back-to-back Zoom calls. I don't know about anybody you, but sometimes towards the end of the day, I get a little bit of fatigue by just being on these back-to-back virtual meetings. And so let's keep this as lively as we can. I definitely encourage everyone to leverage the chat feature in Zoom. While we couldn't meet in person today, obviously, just as we must, which I will go through, we must embrace the cloud, which I'll cover today. Let's embrace some of the positive things about doing a remote learning experience, that it's extremely easy to open up the chat feature and throw out your questions and comments with about 200 people in today's attendance. Let's leverage really our collective knowledge of the group. And if you have a question, it will most likely be a question others are thinking. If you have a comment, please mention it. I'll monitor the comments as best I can, and I'll ask our team to speak up if I miss any. Also don't hesitate to raise your hand either, and we'll work to unmute you. My presentation will last really, I guess, towards the evening. No, I'm just kidding. It'll last. I've got really a couple hours here, and definitely encourage that that collaboration. So also thank you to Deborah for her fantastic presentation. So I'm going to go a little bit deeper into some specific security and compliance topics, really focused on today's cloud environment, where Deborah mentioned about the volume of data that continues to grow. Cloud technologies and the various applications are really enabled in this ecosystem are what drive, in my opinion, this enormous amount of explosion in data. So today's agenda, jumping right in, we'll start with some cloud updates and trends, which will also touch on the important topic of shared responsibility and the perspectives in today's cloud environment. This will set us up for speaking to the litany of frameworks and regulations out there and how they tie back to the cloud. And I'll discuss how these frameworks are really a common language for embracing the cloud. And then we'll get into some risks and controls and dive into one of the most common cloud environments with AWS. That's certainly not to leave out others such as Azure, GCP, Heroku, and others. I'm happy to speak to those environments as well, but you will hear that they have the same fundamentals really when addressing security and compliance. So I thought we'd just take a little bit focus on one to get a little bit more deeper dive. So I'll talk about protecting AWS workloads. And then of course, like I mentioned, Q&A throughout. So before we jump into it, a quick background about myself and our firm, and our mission here is that, really, if you guys want to start answering these questions on chat, please do. Who feels at times completely overwhelmed when you're faced with a complex problem? See a few coming through at times. So quite a bit. Yeah, there's another one. Thank you for that. The interconnectedness of the world we live in today, it's insane. And it's the fast-paced velocity of the cloud and other technologies. We got some depends. And the cloud and other technologies makes things extremely complex. But what I'm here today, in really our mission as a firm, complex doesn't always have to equal complicated. And I founded BARR Advisory 6 years ago with a team and great team and partners I'm fortunate enough to be working with, that we decided to exist to simplify the path to security and compliance for a more secure world. There's a lot of complexities that come within the field of cybersecurity. We believe there's opportunity to focus on what's essential that creates more value for stakeholder objectives, that also safeguards the integrity of the information ecosystems we all depend upon. And so how we serve our mission with focus on innovative tech companies and cloud service providers. So I hope to share this experience from at least our dedication to working with these types of clients since our founding. We didn't initially set out to be a niche player in serving cloud service providers, but these providers over time just demanded that we learn their business, and they've in turn demanded our services. And prior to BARR, I spent most of my career at KPMG working primarily in telco, working with network engineers and switch operators, and we've come a long way since dealing with 3G networks, and with all the 5G rolling out and really essentially rolled out for the most part. It seems like technologies are merging again in how we are processing workloads from cloud service providers to distributed telco networks. And so we view these technologies as the building blocks of business, the Legos, if you will. The agility of the cloud offers powerful solutions, and even state agencies, let's take some recent examples, have gotten in the adoption of the cloud. So Mississippi, they, back in 2009 after Katrina, excuse me, they decided to embrace the cloud, and it really paid dividends today with all the influx of unemployment claims, unfortunately. And but they were able to process these claims at least so there's maybe there's some delays in payouts, but they at least were able to process these claims essentially and make sure that people could make that stake. Another example of this is companies like Airbnb, popular with disruption. And whenever we talk about disruption as Airbnb, they almost entirely run their 200 million plus customers using AWS since the beginning, which, by the way, was founded in 2008 at the height of the financial recession. And now fast forward over 10 years later, in today's pandemic times, they plan to move forward with an IPO. So there's always opportunities in these types of crazy times. And they've recently shifted away from short-term to more to longer-term residential listings, and a lot of this stuff is powered by this agile technology that we speak of. And so when we say that we serve innovative technology companies and cloud service providers, that doesn't necessarily always mean that these are actually technology industries. So what I find interesting with cloud is, and I'll talk about this later, is it's not really emerging anymore. There was a publication in the Harvard Business Review in 2013. A gentleman by the name of Nicholas Carr presented that IT doesn't matter. And his more thought-provoking thesis in that article wasn't that IT is useless or that it doesn't matter, specifically to being in business, is that companies, I think, have overestimated the strategic value of IT, which is becoming ubiquitous. Cloud is ubiquitous, IT is ubiquitous, and therefore a diminishing source of competitive differentiation. And written in 2003, I think there's still truth to that today. While I disagree with maybe the literal argument that IT doesn't matter, I believe what this really means is that if organizations are not participating in ubiquitous availability of IT, then they will not be competitive and remain focused on their core competencies. So overall, we as auditors, we must understand that aspect, and we must understand the business aspect of these technologies and why we are using them so that we can adequately address the risks. So as Sarah mentioned, here's a quick overview of our services. So what we do, I talked about the why, I talked about the how with the service companies and their service providers, and then what we do is really broken out into two buckets. Everything except for the last two is really attestation and assurance related, and then the last two are more consultative related, with especially Cso Advisory, virtual Cso services really growing extremely fast. What we feel like is that gives us perspective, and I challenge any auditor that to start to rotate into some of those more consultative type aspects of the work that you do, because it gives great perspective. Not only being able to audit and go through the audit programs, the checklist, things like that, but also getting that perspective on the consulting side and actually building these things from the ground up. It gives great perspective, and it keeps you sharp on the audit side. So cloud updates and trends. So what is the cloud? As I mentioned before, let's not complicate it into something that's extremely mystic. It's the basic concept of a bunch of servers. It's really just a bunch of servers for processing stuff. So Linux, obviously the most popular that's out there today. The fundamental question is really, who is responsible for processing such workloads? That's the challenge with the cloud environment. And that's the challenging question between the feeling of security versus the reality of security that I'll speak with in a minute, that Deborah touched on as well. So these are the cloud models. Who's responsible for what? And this is what we must understand first. This is a slide I've been using for many, many years. And so I'll go through it quickly. There's also other iterations of this, like pizza as a service, if, for those of all that remember some of those. And so, maybe just by chat, quick chat, who's seen something like this before out there when you see just the different types of cloud models broken out this way? Many times, yep. Great. So that's good. I won't I won't spend a whole lot of time on this, but what I want to get to is what do you guys think is missing here? What's missing in this model when it comes to the different types of cloud models? Is there anything that's missing, not from a model perspective, but in terms of the responsibility? I see security as a service. That's pretty close. It's who's accountable for this stuff. You know, even if you get down to the SaaS piece of it, managed by mostly the cloud service provider, there's that accountability aspect, and we can't ever lose sight of that. You can delegate everything but accountability, and security and compliance is what you're ultimately accountable for. So whip out your RACI matrices and be sure that there's always somebody holding that CSP or cloud service provider accountable for the requirements that you have for them. But always understand that business aspect. We can't assume that our cloud providers are handling everything. It's your business to know about it. And one way to break that out, at least draw the line in the sand, is why most cloud providers such as AWS and many others have the same type of responsibility model. It's called the shared responsibility model. And this is what needs to be orchestrated properly so that it's clear, crystal clear, who's doing what. And so AWS has this concept of they're responsible for security of the cloud, which is the bottom section here with the various software, the processing of the workloads, even some of the security of these workloads. But it's up to the customer for responsibility of security in the cloud. And so us and AWS as customers, when it comes to the data, that's something that you're ultimately responsible for, and you have to understand what as things drift and configurations drift, what ultimately you're applying to these environments. Another example of this, there's even cloud within the cloud. So VMware, for those in organizations that are maybe still working to adopt some of these cloud environments, a lot of times they started with VM, some virtual machines out there, maybe on their own. VMware actually offers a cloud service that's on AWS. So this customer concept is still the same in terms of responsibility, and then VMware actually has their own console that they leverage AWS and the elasticity that AWS offers. So it's almost like a cloud within a cloud, if you can think of that. So in other words, they basically wholesale services for you. So they get a better rate on some of the AWS services, and you can reap the benefit of that. So knowledge check number 1, Mel. So this knowledge check, who's held accountable for security and compliance for cloud models?
Okay, closing poll.
Okay, great. So excellent. So that might have been a little bit of a trick question, but it is both users and the cloud service provider. There's accountability on both fronts. The important thing is that you can't shirk your accountability. You can delegate that responsibility, but you certainly can't shirk your own accountability of what you're pushing out to the cloud or pushing out to the customer. And that's apparent in why these shared responsibility models are so important. So is history repeating itself? The history is important, I mean, in anything, and it's important to understand the world we live in with the cloud. So before the marketing department really coined the phrase cloud, we had back in the 1950s time sharing concepts. We were using these concepts dating back to the 50s with the mainframe computing. To save money, companies needed a way to find multiple ways for multiple users to share CPU time. Basically in the 50s, we just had one giant computer that did that. Then in the 1960s came about the intergalactic computing network. This is the networking concept, similar to how the internet works today, but I'll discuss in a minute about how the internet was a lot more open in the past. So it's become a little bit more closed in recent time. And then the 1970s start to expand a little bit into this Unix area and open source. We learned how to essentially connect these giant computers via a dumb terminal through Unix. And then you start seeing a shift in the 80s. This was the PC era. Next came this era where every household had their own way to connect to a larger set of computers from a distance. And this essentially catapulted into the 90s when you started to get to this distributed computing environment. And then Salesforce ignited the SaaS model that brought computing back to more of a centralized like resources. So kind of back to that similar mainframe concept. So we went from distributed, now we're sucking in all that data from to a centralized component of that. In 2006, that's when EC2 or Elastic Compute Cloud came out with AWS, kickstarted really the platforms and infrastructure services that we use today. And this derived from Amazon when they needed to support their fast growth in the online retail sector, and they decided to create their own cloud, which created a large infrastructure that they then turned into another business model to sell to the public. And then things really took off in 2009. No longer did you need a desktop thin client or GUI on your desktop. You essentially had Web 2.0 that shifted all of the processing really to that data center. You didn't have a whole lot of processing other than the browser on your local machine. So these are all browser-based applications, and it really started talk about building these businesses and the Lego blocks essentially that we have. That Web 2.0 really helped make that happen. So today we still have that robust computing power of the mainframes, which isn't, I wouldn't say it's dead yet. So let's not fix what's not broken, but we still haven't fully embraced the cloud. I think we're getting a lot better, but the cloud's not an emerging technology anymore. We have to really keep up with this technology. So I'll get into a few emerging trends today. So let's talk about these. And one of them is hybrid cloud to more edge computing. If you've heard of, has anybody heard of edge computing? If you could throw into your chat box. Who has not heard of edge computing? Okay, we've got a few. Great. So edge computing is something that it's here already, and it's more about real-time processing, quickly making an impact in some of the business processes that we do. So what this is doing, implementing edge solutions, basically breaks down that centralized data center, which everything really starts at the data center piece from powering these networks, but it breaks down that centralized data center in the way we can process things faster, more consistent user experience, lower latency, highly available apps for organization in the industry. So as things like, and this is really helping with things like technologies like artificial intelligence and machine learning, as those are becoming more prevalent, the need for that information in real time becomes critical. So think of the use case of a manufacturing plant. So robotics and just-in-time manufacturing systems mean that computing is already ubiquitous, that we talked about before. But if that infrastructure is supplemented with things like video and telemetry systems with these real-time analytics, that use case for that is that worker safety can be enhanced, maintenance issues can be anticipated and managed autonomously, and resources can be allocated to the highest value type activities that improve overall productivity. But what edge computing does, it further improves infrastructure resilience because it brings that processing power away from that data center that might be far away to systems and applications that are more closer to you. And that provides that low latency given the extreme amount of data that needs to be processed in real time in today's environment. Sometimes the pipes that we have out there today really aren't sufficient for the amount of data that we're trying to process. A few things though, edge computing is not possible without a hybrid type cloud environment, and the foundation of edge computing, it must be open or will fail. So if we're using a wide variety of platforms or Internet of Thing type devices, it has to be an open environment for systems to communicate with each other. And speaking of open, This is where we get into what's called deplatforming and a decentralizing of data processing. So I talked earlier about the internet's changed quite a bit over time. So it used to be a lot more open than it was today. And there's a reason why it's a little bit more closed. There's some security considerations. But we have this is more of an idea at this point. I wouldn't say it's really taken off yet. So this is something to think about as we're building some of these programs, as we're talking about some of these emerging things. So bear with me for a little bit. This is an interesting concept that it's just inevitable with some of these emerging technologies like blockchain, yet I think it could occur a little bit sooner rather than later, given some of the pressures that the big tech firms are facing today from the regulators, such as the recent Amazon, Google, Apple, and Facebook hearings in Congress recently over the summer. So over time, like I mentioned, the internet has gone from this entirely open network of systems and computers to where most of the services and interactions we have on the internet are gated by just a few companies, which essentially silo the data that we're using. There's pros and cons of this, of course. There's reason for it. Essentially, while us as a consumer, we give up our data for free. We are the product, and the data is that good that's processed through these, select few gateways, essentially. So some call this the winner take all model. And this existing centralized model, where a lot of this data is processed by a select few, it's convenient for the consumer, us, so that we can navigate fairly seamlessly across the internet, from making purchases to posting our favorite memes on TikTok and the like. But how does this really relate to a cloud security training that we're talking about today? The reason is the data component. We have to follow the data always, follow the money where it's going. What a potential deplatforming of data processing is, it opens up data that our organizations process where it is no longer protected by virtual networks and database security controls. That might sound like an issue, but rather through some of these emerging technologies such as edge computing and blockchain, this shifts the data from being siloed within a few select companies to being distributed everywhere. Since blockchain as a technology is decentralized in nature, it doesn't rely upon one central point of control. And it's hard to imagine that if this extremely sensitive content is on everybody's machine, these machines are essentially acting as that digital ledger of transactions, with every computer having complete copy of the data. So a lack of a single authority argues that it actually makes the system more fair. It makes it considerably more secure. And instead of depending upon a central authority or a central control point to securely transact information with others, the blockchain potentially has the potential to use a set of consensus type protocols across all these nodes in our environment. And that helps to validate transactions, record data in a manner that's incorruptible. And as blockchain is a ledger of information, it is extremely important that that information being stored is accurate. And so since the data is saved on multiple computers, it's extremely secured, even if one or two computers malfunction or even get ransomware. So it's a little bit hard to imagine, throwing some of your most sensitive EPHI and content on a distributed ledger. But the concept of it is supported by the technology there, that to keep that same fundamentals of confidentiality, integrity, and availability of the data. So I only bring this up because history has proven time and time again over the breakup of centralized entities, and for example, the breakup of AT&T with the Bells. And I suspect that history might repeat itself. Another emerging, maybe not so emerging now, but becoming more popular, is this what's called monolithic architectures to a more microservice architecture, which I'll get to on the next slide. So I apologize about it's a little bit fuzzy, but essentially that the microservice is also known as a microservice architecture, is an architecture style that structures an application as a collection of services. You look on the left-hand side of the screen there, monolithic architecture is more of a, you've got one user interface and it interacts with the business layer and data interface. Let's think of this as just like a traditional server database model, and all services from the, if you have an e-commerce site, from payment checkout to shipping to procurement of the order. All of those set of services are really tightly intertwined within kind of one stack, essentially. Whereas you look on the right there with the microservices architecture, it's loosely coupled, but it's independent. So it's independently deployable. So all of those different microservices are, think of those as segmented, one set of services. Like one service might be the payment cart, another service might be the order procurement, and another service might be the actual shipping component or account inventory. So the microservice architecture enables more of a rapid, frequent, and reliable delivery of large, complex applications. But it also enables an organization to evolve its technology stack, because these different microservices have kind of self-contained containers, which I'll talk about in a minute. And essentially, you can own these different individual microservices with smaller teams. No traditional change advisory board needed, essentially, to make sure that any change goes in the application. If I want to make a change to the payment cart, it's not going to impact how orders are processed. You can actually just make those changes directly to that microservice because there's no impact to the other set of services. Does anybody use or seen microservices at their organizations? If you guys can go them in the chat, just curious. Started to go down that path. Excellent. Yeah, it's been around for a while, and it's kind of just starting to take on with a lot of companies. So it's good to see that you folks are seeing that too. This is the definition. It's by Martin Fowler. He's a pretty infamous developer. So microservice architectural styles and approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, often over HTTP or resources or API. It's kind of a vague, really, definition. My own kind of definition, if we get into it, is really, it's like an IKEA box. This is a meme. You got Ryan Gosling putting up here that how easy it might seem to put an IKEA desk together. But if you guys have ever put it together, an IKEA desk, it's complicated. But the fact of the matter is that you can put everything together based on only what's in that box. You don't have to bring your own screws. You don't have to bring your own screwdriver, drill, etc. They even give you those little axles as well, Allen wrenches as well. And that's something that is how I kind of analogize the microservices, because these types of container services make it possible for microservices to happen, because you can containerize all these entire products in kind of one containered service, and then they just start talking to each other. So there's a question, does microservices risk lack of overall integration? Absolutely. And I'll get to that in a minute, about how we need to come up within these architectures. You have to come up with an open API architecture so they can actually communicate with each other. An API is one of the biggest risks to microservices and how they're functioning. Great question. So I talked about this a little bit earlier. So with all of this complexity that's going on, there's usually two different schools of thought. You got one hand, security versus the reality. So Bruce Jenner coined this, that security is two different things. It's a feeling and it's a reality, and they're different. And sometimes we feel secure, but the reality is that we're not. And sometimes we are secure, but we don't actually feel secure. So the reality of a cloud environment is that they are indeed secure, in my opinion. So why is there so much feelings out there of being maybe insecure in the cloud? Just by maybe some yes or no, who feels like cloud platforms are secure and who doesn't? Just maybe yes if you're secure, or no if you don't think they are. Got a lot of yeses. That's good. Got some no's. Maybe. Yep, depends. Larry, yes. All of the above. So, I think this concept is that usually it's the unknown that makes us not feel secure, or maybe gives us a false sense of security. And so you got some folks, like sometimes executives, oh, that's in the cloud. We don't really have to worry about that. that's really about understanding. You have to start really understanding what's going on. So how I relate this back to the presentation, we can be guarded about this stuff. And how this gets back to, I think, a debate is really what's compliant versus being secure. Target was PCI compliant when they were breached. That doesn't mean that PCI has failed us. Absolutely not. Compliance is a baseline, and these standards are needed. And as Deborah mentioned, use these rules and regulations as ammunition to get these programs going. But we shouldn't stop there. Let's think if IKEA decided, well, we shipped out the box of tables and chairs and all that type of stuff, but they decided, you know what, we're just going to stop putting the instruction books in there. That you need that stuff, because while you can put together that furniture without the instruction book, maybe that instruction book's kind of nice. So they might be compliant if they're shipping stuff out like that, but the reality is you need to go beyond just the basic blocking and tackling of compliance. So compliance versus security, is there a difference? Absolutely, but they're interchangeable. The reality is compliance plus security is what equals trust, and you have to have both, and you can't just stop at compliance. You can't just stop at security either. We work on a lot of due diligence with our clients, both from a consulting basis as well as when we're figuring out if we want to do business with the attestation clients. And when I hear that, hey, we're just in it to get the checkbox compliance cert, we run away as quickly as possible from those types of companies, because they're missing the whole intent of the compliance and regulations. It's the pursuit, the pursuit of happiness, the pursuit of real security. Is it always has to be maturing. Knowledge check number 2. Mel? Yeah, so we're going to get into some general stats, but what percentage of your system workloads are processed in a public cloud environment? So we've got more than 90, 70 to 89, 50 to 74, or less than 50.
Okay, I'm going to be closing the poll.
So this is interesting. So it seems like the majority is less than 50. So we had about 6% more than 90. We had 10% 75 to 89. 25% of the group is about kind of half to 74%. But almost 60% less than 50. That's interesting. And I'm curious if is anybody seeing more of a trend, though, to be pushing more to the cloud? If you guys can answer by chat. Yep. So what I'm showing here is a study, or a survey, if you will, by O'Reilly. It's interesting. An interesting number of respondents said that 25% said their companies plan to move all of their applications to a cloud context, and this was just done this year, in the next year, so 2021. And 17% of these respondents were from large organizations, 10,000 employees, and we got one yes as we convert legacy systems. So yeah, that's a big deal, converting some of these legacy systems to a cloud environment. And I'm not saying there's a right or wrong answer to it. It's just that's the trend. That's what's happening. And as this survey alludes to, some companies have already been there. They're 100%. And so cloud workloads, they continue to increase across public, private, hybrid cloud environments. And another interesting thing about what's going on in the cloud environments, that some of these investment reports that I've seen, while there's still growth that continues to be in the cloud, the velocity of that has decreased a little bit. So it's a lot of growth, but it's slowed down a little bit, and that's an indication typically of disruption, that there's a lot of maturity already going on in the cloud technology business, and there's going to be some new disruptive technology on the horizon, like I mentioned before. A few other interesting notes in this survey is that public cloud dominates, but most organizations do use a mix of cloud options. Almost half continue to run, and I guess that's somewhat in line with the polling, but almost half continue to run applications in a traditional on-prem context. More than half the respondents of this survey use multiple cloud environments. AWS, far and away the cloud leader, but they are losing market share quickly from Azure and GCP or Google. Most Azure and GCP users also use AWS, so the reverse isn't necessarily true. So this gets back into our organization still concerned about cloud security and compliance. So 91%, according to this Spotlight survey, responded they're concerned about cloud security. Yet we are still seeing progress in that at least a majority, as you can see on the right, 57% believe the cloud apps are as secure or more secure than on-premise applications. So we finally have email in the cloud, and IT now realizes they can't fight the shadow IT anymore, and we're putting policies on collaboration sites like Dropbox, 365, and Box. And this is really, I think, goes back to where's the anxiety is there's still concern. And ironically, 57% believe it is secure. So a whopping 18% though have no idea. And so education is needed. Going to things like trainings like this is important. So my opinion is that most, not all, most cloud solutions offer better security, but the issue really lies in the skill sets. And do we have the people that are equipped to handle and manage some of these and be held accountable, quite frankly, for security? So this survey, what are the biggest barriers to holding back cloud adoption in your organization? And 42% said lack of staff, resources, or expertise. So training programs are needed. A few examples, there's some certs out there like Cloud Architect certifications, there's industry forums, there's a plethora of conferences that the major cloud players offer, like AWS has they have reInvent, which is kind of their AWS just general conference, but they've also recently have put together a conference called Reinforce. It's more specific topics around information security specifically. So the good news is that in the previous surveys before this one came out, thought that more budget and tools would equal better information security in the cloud. So that's, I think that's a completely. Associated with VPN. Was that a question, or is that somebody maybe accidentally going on mute? Maybe. No. So I think that's a completely wrong thought process. I think culture and people are the drivers here. And so the people are the ones that should tell you the tools versus more spend and more, and I think versus the people is going to be a better security approach. So what are the risks? So we were familiar with the cloud models. So we've got the SaaS applications. These are like the people and goods, if you think of kind of the road analogy. Then you've got the infrastructure as a service. These are like the roads that kind of allow the infrastructure to be to ship some of these goods. Then you have the platforms or platform as a service. I think of these a lot as like the Devops boom that we've seen over the past decade or two. And these are like the vehicles. So these are the containers that ship that basically traverse the roads and carry all the people and goods. So what are some of the risks? So account hijacking with SaaS applications, inadequate identity and credential management managed by the business. So we've got a lot of these SaaS applications, they're not really under IT anymore sometimes. And then we have accounts hard-coded in third-party applications. That's an issue. One way, I guess, of communicating with other applications is just hard-coding the passwords. That's certainly an issue. And then external sharing of data. You hear almost monthly in the news about it, an S3 bucket accidentally, or a Google or Office 365, what have you, just accidentally being shared to the public. And I think there's a lot of different types of controls. We'll get to that later on in the presentation, but the Verizon data breach report, 8 out of 10 approximately hacks really start with this whole account hijacking or credentials being compromised. I've been part of kind of incident responses, and it sounds like Deborah and I don't think this is the same client, but we had sounds like it might be common. We had a $4 billion client that they had the same issue that Deborah mentioned about their payroll got rerouted to the hackers' bank accounts, and they were in the system. These hackers were in the system for about a little over 6 months, and they stole everybody's identity. Once they stole the identities, they set up fake bank accounts in the people's names, and so it was really easy to route all that payroll. And something as simple as multi-factor authentication could have prevented that, because what happened was it was a Workday compromise. So Workday got compromised, and it wasn't Workday's fault. They did see a surge in hacks, but they enabled multi-factor authentication, but this administrator just didn't have it enabled, and something as simple as that could have prevented this issue. The other issue is that they didn't have any alerting turned on that notified people of their bank accounts being changed. So that's while it seems obvious, hindsight's always 20/20. So on the infrastructure as a service, so some of the risks, so abuse of services, external sharing of data, again, like I mentioned, mismanaged account keys. Now we've got a lot of programmatic accounts talking to each other. Same with insecure APIs, more APIs to manage and this should say server, less servers. So, essentially you can get into this concept of serverless, and the APIs are really help to manage that. And then you've got platform managed by developers, engineers, and the business versus IT. So this is the merging of maybe think of like DevOps or DevSecOps, where these DevOps groups are really managing it versus like a traditional IT that's managing the network. Abuse of service is big. I had a small client, and I think the point is that everybody's susceptible to this. They had they're about a $3 million company. They had a $100,000 AWS bill for services they never even used in their core product because their development environment got compromised, and somebody started just mining Bitcoin off their environments. That's a significant amount of processing that they consumed, and this company was stuck with a $100,000 bill. I think they eventually worked out a deal with AWS, but those abusive services happen. Risks in the DevOps world, if you can have any takeaway today, this is something that I think us as auditors focus the least amount on. We're really good at figuring out who has access to applications. We're pretty good at figuring out who has access and managing change to the infrastructure. But we often forget about these are the orchestration tools. No longer is the day of somebody going in and just manually configuring a server. These platforms, things like Jenkins, Puppet, Heroku, Docker, GitHub, where all your source code is stored at, these are orchestrating kind of the puppet masters essentially of the entire ecosystem. And what I think as auditors lack a little bit is understanding how these orchestration systems really impact information security. And what that happens is that I talked about DevOps. If DevOps doesn't have an integrated DevSecOps program, if there's lack of attention to some powerful service accounts that orchestrates these entire ecosystems, and resources change often. And so resources are now being managed by code. You can change your infrastructure, how you open up ports, how you open up IP addresses, purely based on code. And these are systems that are essentially rebuilding themselves on a nightly basis, called immutable infrastructures. And so us as auditors, we can't literally look back and see what was going on 6 months ago, because 6 months ago that was a server that was already rebuilt 1,000 times over. And so we have to really test the processes versus the individual. So how do we understand the process of how our clients and how our organizations are implementing DevOps platforms? Make sense? I'm not going to go through this entire slide here. I just want to, for reference, since these are going to be sent out, is that this is a great tool. These guys have actually changed their name since, but it's the periodic table of DevOps tools. There's so many tools out there. It's tough to organize in your head. You're not going to remember them all. I often reference this, this periodic table if I ever want to know about things like, okay, I want some source code management control. I want to understand if there's any tools with continuous integration, et cetera. Great resource. I highly recommend checking it out. I touched on infrastructure as a code earlier. Maybe you guys have heard the Facebook motto. My motto is move fast and break things. Jobs have been fired from FedEx driver, crane operator, surgeon. There's some pretty significant essential services essentially that we want to make sure we're not just moving fast and breaking things. It's a great motto. We just have to balance that because regardless of if you're in a cloud or on-prem environment, we have to have an infrastructure that can handle breaking things and still be resilient. So code management processes, we need to deliver backup plans that we can store in minutes. And if we don't get this right, if we don't get this cloud security aspect right, we won't be prepared for when it comes to time for edge computing and the billions of distributed processes out there. So as you guys know, Facebook, since their hack and more recently decided to move fast with a stable infrastructure. So keep that in mind. Security as code is something that is a auditor's dream. If you can bake security, this is really comes into when you hear security by design. You know, there's the feature aspect of it, but then behind the scenes, if you can bake in security in your code, that gets you into that process of understanding the velocity of changes enabled by DevOps has demanded this DevSecOps, as I mentioned. Infrastructure as code has enabled you to build security as code that I'll talk about in a minute, some of the things that you can do. And then using continuous integration or continuous delivery as a control backbone. CI/CD tools, those are common tools that, that basically are continuously integrating, continuously checking the integrity of your code base all the time in your DevOps pipeline and deploy chain. How awesome would it be from a change control standpoint if as you're essentially rebuilding your environment every single day or every single minute, as some environments are. Think, how can a hacker really compromise you if you're kicking them out every time you rebuild a new infrastructure? That's awesome. And so that gets you where you're less dependent upon these ticketing systems and access controls, where you're really just, the code actually has those instruction sets embedded in it. So definitely keep this in mind as you guys are moving towards your audits. So I'm going to go through this quickly. I just think it's always interesting that, you know, there's the gold rush, there's the oil boom, and now we're at this kind of data generation. And data is king, as we all obviously mentioned before. These are a couple stats about from Ponemon about just the average cost of the breach. You know, technology doesn't matter without the data, and there's a lot of data out there where maybe the boomer generation might have most of their data local. It's becoming near impossible today to be completely off the grid these days. So we all have data exhaust filling up these systems in all forms. So we'll get into the knowledge check next. You know, we're about halfway through. As we move into some of the key controls that you can put in and some of the regulations, what are some of your guys' current challenges, if you can open up the chat, or concerns when it comes to the cloud? What do you guys care about? What do you not care about? Yeah, privacy, that's a big one. A big breach at a major CSP, that talks to the centralization of data. That's an issue, right to audit, Hipaa, PII, we'll get into all those. Great. All of the above. So knowledge check number 3. What is an example service model for cloud providers?
Okay, we need to close the poll.
Awesome. We know our cloud models, all the above. SaaS, infrastructure service, platform as a service. So good job, guys. All right. So, speaking of, HIPAA, PI, right to audit, industry regulations and framework applications, how some of these things apply to cloud environments. So I think it's important to just break this out into three things. And this is obvious with this slide, there's many choices, but you have your frameworks, you've got your regulations, you've got your reporting, and really the reporting certifications are really about trust. It's not, I wouldn't call these things required, but it's how do you kind of get that trust from an audit standpoint, whether you're reporting out to internal stakeholders or external stakeholders. And I'll run through a few of these, but essentially, like I talked about before, the blocking and tackling really comes with establishing a framework and complying with it. Let's not stop there. The good news is that what's evolved over time, these frameworks have adjusted over the years with a heavy focus on risk management. ISO at one point back in the 80s and 90s, they tried to, at one point, tried to create a prescriptive kind of process for every single scenario, but that's just not possible today, and they've recognized that. And ISO and a lot of these other frameworks have really focused on, especially HIPAA as well, on risk management. What are some addressable controls versus required? And the addressable ones really have to be focused on risk. Who can tell me what's the best framework that's out there? Can anybody have any thoughts on what the best one is? None? Not a best one? Not HITRUST? I share that sentiment. NIST? Depends on your needs. Yeah, I think all of this is accurate. I think that, in my opinion, depending upon where you're at in your organization, and one that the company will follow, I love that one. That's to me, that hit the nail on the head, because it doesn't really matter which one you pick from a framework standpoint. I know you have to comply. The compliance piece is inevitable, but you can comply with any of these regulations by having a framework in place. So pick one, go with it, be consistent. You can get into some of the mappings later, but you really have to pick one and go with it. And one that the company is going to follow is, in my opinion, the best one. NIST and ISO are probably the most popular that are out there from a framework standpoint. And I'll talk about in a minute that there's ways that you can really combine all of them, but you just got to pick one and run with it. The regulations and industries, so GDPR it's been around for a few years, so you guys should be familiar with that, but it's more of an opt-in type regulation, where CCPA, which is a little bit more recent, is more of an opt-out. They already have all your data. They just have to make it really really clear on how the user can opt out. So yeah, and there's a comment, I would love it if we had just picked one. Yeah, it's about focus. It's about reducing the complexity out there. There's too many things to worry about, and most of these frameworks are fairly comprehensive. Reporting and certifications. So HITRUST is an interesting one. They've been extremely prescriptive over the years, and it's a beast. I think really just a little bit of context with HITRUST really started catapulting when Anthem got hacked, and some of the folks within that kind of I guess post-mortem started to mandate HITRUST to be on their programs. So it's kind of mandated in the industry and some of the healthcare industries. But yeah, it's a difficult one because it is pretty prescriptive for sometimes the value, but there's some good stuff in there. So I'm gonna try to remain as objective as I can. And then the only thing I'll note out here is that this is a relatively new one, ISO 27701. So there's some questions about privacy, and this is a framework, but what I think is different about this one specifically is that there's really not, at least there hasn't been, GDPR really hasn't kind of put forward and say, here's the way to get certified against privacy. ISO is really one of the first ISO 27701 is one of the first standards kind of reference GDPR in its program. It was released August 2019, last year, and it was the first international standard with a mechanism that allows organizations to undergo an independent review of their privacy programs against prescribed requirements for protection of PII. So there's some certification bodies out there that are offering accredited ISO 27701 certification. So something to kind of track over time as that continues to evolve. And as we're trying to figure out how to really comply with some of these very high level privacy rules. Key frameworks. This is a top-down view. Starts with your business goals, the drivers of the business goals, as well as conformance, so GDPR, contracts. So that always has to be the driver. That's how you really assess risk. Enterprise governance, that's when you get your scorecards and your Cso framework. IT governance, that's when COBIT, if you like COBIT. And I just want to mention this just to show you, if you do happen to have a lot of different frameworks in your organization, this is a good way to maybe organize it in a way that makes sense. I still am a firm believer in picking one and going with it, but some companies are too big to really have one opinion on that. And so this is the way to really harmonize those a little bit. And then when you get down to the frameworks and standards, the level, this is in order of prescriptiveness. So you get into SOC, this is SOC reporting, not the Security Operations Center, but SOC reporting is very high level, sometimes to a fault where you're not really sure which controls you should implement for SOC. NIST and CSF, a little bit more higher, a little bit more prescriptive. And then you get to ISO, that's even more prescriptive, especially with some of the policy and documentation requirements of ISO. CIS top 20, you kind of get down to more the simplicity of basic blocking and tackling. Then you got your Cloud Security Alliance that has more specific cloud specific framework for controls. And then what I love is the CIS benchmarks. So this is a little bit more further prescriptive than CIS top 20. If you guys are ever in not sure of how to audit something, it's a new system, most likely CIS has a very prescriptive way to audit these systems, even down to the command level. What command should you run on your Heroku environment? What command should you run on your AWS MySQL instance? And those are some great tools that I always recommend being kind of in your toolbox for equipping yourself with the audit. And then you get into some different procedures and how these all harmonize. So there's the standards, which usually drive into policies. And then you get down to procedures with things like asset management, vulnerability management, admin privileges, log analysis, et cetera. So going in more specific with the regulation considerations. So again, they're all risk-based, some are addressable, not all required. GDPR, data inventories is significant. And, with all these systems, we're seeing a lot of companies essentially buying cloud products to connect, almost like a CASB that I'll talk about later. CASB is basically a cloud security broker, and it scans all of the data out there. And it not only manages consent, and if you guys are looking for some tool recommendations, I'm happy to email those out later on, but there's some great tools out there that are coming about in the marketplace that not only is just a bunch of questions, but also it actually scans your environment. It manages the collection of consent, and it manages all these different disparate, decentralized kind of cloud products that are out there and workflows for processing things like subject access right request, processes things like hey, I've got a breach. Did we meet the 72-hour rule requirement for notification? Individual rights to compensation. That'll be an interesting one as maybe centralization takes place of who owns the data. It's tough to monetize off your own data when it's all governed by kind of one entity. And some of these decentralization process, you could start getting paid out in Bitcoin. So that'll be interesting how that unfolds. The cloud processor due diligence of their customers. A recent ruling on July 16th of this year, 2020, the Court of Justice of the European Union, basically the EU's High Court, they ruled that Privacy Shield certification does not adequately protect the data of EU citizens from the US. So they think that our surveillance activities are not commensurate with what's going on in the EU and what the expectations are. So it's essentially saying that the US law does not have the same level of protection required by GDPR. And because in the US, the interest of national security, public interest, law enforcement, all these fundamental privacy rights considerations, the US did actively participate in the case and provided the court with all this understanding of what's going on. But essentially it ruled that Privacy Shield isn't adequate. So what does that mean? In short, be aware of training of folks trying to promote Privacy Shield. Privacy Shield is fine, but when you're asking about GDPR efforts and dealing with maybe your EU counterparts, Privacy Shield is no longer really a valid kind of answer for basically moving data to the US or other countries. And while the ruling stated that Privacy Shield certification is not adequate, it did leave open the use of what's called standard contractual clauses as an appropriate mechanism for onward data transfers. So this might, in the end, not really mean a whole lot as long as you have good contractual clauses governed by GDPR. And I suggest that your data processors comply with both the clauses and Privacy Shield. So to be clear, the court's decision does not relieve all of the, I think there's over 5,000 organizations that participate in Privacy Shield. But the US is still trying to figure out what to do with it. So they're studying the decisions and determine the practical impacts on the regulations. I'm curious, who's heard about this, and just curious what your organization is doing when it comes to the Privacy Shield and data transfers between EU and US. Anybody brave enough to volunteer? Yep, relying on SEC for the time being. Okay. Excellent. Hipaa, just a few things with Hipaa. I mean, again, not a lot of the differences. Hipaa is a pretty high level set of safeguards. They don't really get too prescriptive. It's important to data inventory from a cloud standpoint, coming up with your incident definition, reporting. You have 60 days to essentially report out on it. The important thing with the cloud and just basically all the third parties that we're leveraging is that if you're using a cloud platform to process electronic protected health information without a BA in place, that's not good. It's something that's pretty much mandated, and from a privacy standpoint, you have to notify these service providers that you're sending them ePHI, and so that really gets into the due diligence around inventorying your service providers and doing data mapping exercises, and all of these. What's kind of the theme here? We got to do a data inventory. So as mentioned by Deborah earlier, it's a very important piece of it. And then she already talked about data retention and disposal SLAs. PCI, I'm just a big fan in trying to segment and make that scope as small as possible. If you can, de-scope it completely. It's a very prescriptive requirement. It's hard to implement. The good news is there are a lot of tools out there. We partner with a company called Initian that essentially has prepackaged templates that you can deploy a cloud environment within literally a matter of a few minutes that's PCI compliant. So there are tools out there that make it easier, but it's always best to kind of trust the pros out there with PCI and do some form of tokenization and P2P if you really have to have access to those not necessarily the numbers, but a way to kind of do refunds and things like that and analysis. So since we focus a lot on SOC reporting, I'll do a real high level. Olivia just mentioned PCI version 4 is that you're correct, is to provide a risk option. So that is good news. That's important to note. And so, yeah, thanks for sharing that. So on this slide, since we do a lot of SOC reports, I think there's, I think everybody for the most part should be well aware that there is SOC reporting out there. That's a big component of vendor risk management. These are very much market driven, but it's important to understand the differences. So There's the SOC 1, which is more focused on internal controls over financial reporting. This is often misused and assumed that this is going to cover your cybersecurity program. It was once referred to as SSA 16. Don't get confused with SSA 18. There's no such thing as an SSA 18 report. It's an accounting standard. And so you got to differentiate between it's either a SOC 1, SOC 2, SOC 3, or even SOC for cybersecurity. But here in the top, SOC 1, that's focused on controls over financial reporting. Operational controls are going to get into your SOC 2 and SOC 3. Essentially, there's no difference between a SOC 2 and SOC 3 from the level of effort and work. It's more just what's on the report. So the SOC 3 is a shorter report. It can be presented, posted on your website publicly, whereas a SOC 2 is more limited use because it has a lot more details about the controls and findings. As we are talking about other regulations, there is the concept of SOC 2 Plus, which you can not only report out on the security, availability, confidentiality, privacy, process integrity, and privacy, but you can also bring in other criteria. So a common area is to bring in things like Hipaa or NIST. You can bring in those programs or criteria within the SOC 2 report and report out on those. And you can essentially get an opinion from your accounting firm on those different criteria, since a lot of those, especially with Hipaa, there's no such thing as a Hipaa certification. So how do you report out on that compliance? And then the relatively new one, SOC for cybersecurity, we haven't done a whole lot of these, but the point of this is that it's more for an entire entity, whereas a SOC 2, SOC 3 is a little bit more focused on a particular system or scope subset. SOC for cybersecurity is kind of a more higher level framework over an entire entity's cybersecurity risk management. And then one that was recently new is just called SOC for supply chain. And it's intended mostly for manufacturing, but given everything that's going on today, supply chain risks are there. And if you're curious about that, I'd definitely look into some of the objectives that the SOC for supply chain reporting requirements that recently came out. And I put this in here more for reference. I'm not going to go through all these different sections in detail, but essentially there's usually 5, sometimes 4. The only thing that I'll point out when you guys are doing your due diligence, definitely always look at this section called complementary subservice organization controls. So this goes back to shared responsibility. So this helps. This is a way in the report to provide transparency to whoever is using these cloud service providers. What are the controls expected of you? If you don't see those controls, then you definitely want to make sure you go to their website to make sure they explain it in more detail. But a lot of times these subservice organization are basically your vendor controls. Those are the ones that they expect, or sorry, mixed up. It's actually user entity controls. The user entity controls are what are expected of you as the user of those services. So you have to make sure that you take those controls and map them and make sure that you're addressing those controls in your own environment. So just left this up here for reference when we share out the slides. And there's a question, should an auditor review the SOC 2 report of their cloud provider? I'm not sure if that, are you speaking more specifically, should an audit firm, if they're using cloud services, review their SOC 2 report that they use? Is that what you're asking? I might not understand the question. Okay. Well, if I understand correctly, I'll just, should it be an internal auditor review the SOC 2 report of a cloud? Yeah, that's a great point. So I think is it between the auditor or somebody else in the organization? I think it's got to be a joint effort. I usually put the onus on, if you are fortunate enough to have an internal audit function, I would always recommend that you have that internal audit function review the SOC 2 report and then work with IT to make sure that they have those controls. Some organizations don't have an internal audit function, so you kind of have to, I mean, you don't really have any other option option, that's where you might want to ask if you're getting audited, maybe your own external auditor to help you out with that. The bottom line is it has to be reviewed, and the auditor's role is to understand the report. IT's report responsibility is to also hold their own systems accountable. But if they're sourcing out this function and they don't have an internal auditor to kind of leverage to with that technical expertise of reviewing these reports, they have to review them. I mean, the bottom line is somebody has to review it in the company. But if you do have both an internal audit function and IT, I would always recommend these reports going through at least making sure somebody's owning it, so the internal auditor can at least check it. So maybe that's not their primary role, but they at least have to make sure that it's documented somewhere. It's kind of who's checking the checker. Good question. So that brings us to knowledge check number 4. What is the best security framework for cloud services?
Okay, closing poll.
So this was a little bit of a trick question. Just kind of curious the response. I probably would have picked other, because it really depends. What what works well, to your point earlier. Which one is the organization actually going to follow and work on? You can always map in other frameworks but any of these are great. So I can't really call out one particular that's better. 27018 is definitely more cloud focused. It's based on the concept of 27001, and Cloud Security Alliance obviously has their own framework that's cloud specific, and then CIS, Critical Security Controls, is pretty agnostic of a cloud or not. Just keeping you guys honest. So key risks and controls. So I like this quote. If you haven't already kind of taken this away, that it's all about maturity. And if you can't fly, then run. If you can't run, then walk. If you can't walk, then crawl. But whatever you do, you have to keep moving. You got to start somewhere. Don't get overwhelmed by all the, where you're at, how you compare to other organizations. You got to start somewhere, break it up, do it piecemeal, do it one thing at a time. And I interpret this quote as that, there's never a day. It's again, goes back to the pursuit that I mentioned earlier. You've got to keep moving. Too many businesses are too easily distracted from their mission as a company at times, and IT is at the onslaught that can't really keep up with all these faster, more agile businesses. Don't let IT systems and technology distract resources away from what's the company's mission, what's the core values, the competencies, and us as auditors have to take these things one at a time. Recognize that it's a continuum, it's a maturity cycle. It's not all or nothing. It's got to be a process that continues to evolve and enhance over time. So some lean infosec controls. This is the same slide. It takes the risks and brings them into actual control aspects. So SaaS applications, we talked about multi-factor authentication, login resources, specifically set some type of trip or alert if something gets publicly shared. How you manage that data governance. Store encryption keys of your data in separate cloud environments. So this is an interesting one. If you have maybe an issue with going back to the point of somebody brought up earlier, what if one of these cloud environments get breached or compromised? What if all your data in Box gets, what if they get breached and get compromised? One way to mitigate that, you can actually, there's services within these entities that they offer that you can encrypt all your data in their environment, and you can store those keys in a separate cloud environment. So that's where multi-cloud environments are interesting in this regard. So if you're really concerned about what you're throwing up in a cloud environment, consider something like this. You know, if you feel like that's a valid risk, you can use a multi-cloud strategy. SAML, SSO, federated identity management. We talked about the issue with just things getting, accounts getting compromised. You got multi-factor authentication, but having some type of single sign-on where it's not always up to the business to manage access. You know, think of this from you know, integrating all these apps into your federated identity management. And then the last piece was identity my Zoom screens. There we go. Yeah. Okay, there's a question, should a copy of the keys also be held outside of the cloud? Absolutely. That's the point of this, is that you encrypt everything, and then Box does not have the keys. So if they get hacked or another cloud service provider gets hacked, they don't have the key to actually unencrypt or decrypt the data. So absolutely. Good question. Oh, what I missed was consider a CASB. So a CASB is a cloud security broker that can really act as that broker between all these different cloud services and essentially monitor what's going on. And there's a couple of benefits, not only from a security perspective, but also from a cost optimization standpoint, to just figure out what's going on in your organization's environment. So the roads, the infrastructure as a service. So we talked about issues with key management. So do automatic rotation. There's no excuse anymore for not rotating your keys. There might be some technical limitations based on kind of legacy processes, but definitely work towards rotating keys, kind of one use aspect. Patching with continuous deployment. Your systems need to be patched. I mean, this is it's easy nowadays. And if your IT isn't really with the times and just keeping things more of a mutable infrastructure, you got to get to this point, figure out a roadmap to get to a point where you're able to patch your systems pretty much continuous upon deployment. The biggest risk factor, I think of all of them, DevOps, and you got to automate your testing, continuously vulnerability testing, pen testing on non-prod environments, because these non-prod environments become production. And so when you're asking questions around change management, say, oh, that's not production. Okay, how do you basically spin up your production environment? Are you just taking non-production? And that's where it's almost important to handle non-production environments just the same as production nowadays. Third bullet point, endpoint management for those with tools on the endpoint. So if you're running orchestration containers and pushing out apps and such on your own machine, which is common in a DevOps world, how are you managing their endpoints to make sure that any malware that they might get on their computers isn't being introduced into the production environment? We talked about infrastructure as code. It's a process. Definitely work towards that infrastructure as code model and then API security. And I'll get into some specifics to microservice as well. Some of the same themes here. So common control considerations within the microservice environment is API hygiene, including inventory, testing, auditing. Facebook, we talked about that. Huge data breach, 50 million accounts were stolen. Reportedly that was theft vulnerability was introduced in Facebook's code. A lot of it was based on kind of some API things going on. They didn't really have an adequate inventory of what was going on. Authentication of API consumption. This goes back to API key, access token, and short-lived certs or certificates. Let's expire these things. We talk about retention and disposal of data. Your data also includes these different certs that are on your environment. Credential and key management, rate limiting. You can read the rest. I think one thing that I always find interesting, and if you haven't heard of this, well, I'll kind of poll the group real quick. Has anybody heard of the Netflix Chaos Monkey? I think it's a great, if you haven't, look it up. It's awesome. It's basically, what they decided is that if we're going to really have a true good environment, let's actually randomly terminate instances on our production environment to ensure that engineers are implementing all these robust practices in their environment. So they're essentially going in production, testing this stuff in production by killing instances. And if you have a true set of microservices, if you have a true set of redundant nodes and environments, this kind of chaos monkey that's going around disrupting your environment is a way to validate that. You know, don't do this thing once a year. Somebody have a question? No? Couple other things. These are just some basic lean infosec, and I'll skim through these. That you know, basically, these are blocking and tackling of information security. You know, you can get caught up in all the standards. Most of them come back to these types of things: endpoint, mobile device management, using the latest OS, internet connected applications. This is just updating, basic blocking and tackling. A lot of breaches happen because your OS is out of patch compliance. Weak passwords, we talked about that. Encryption, multi-factor authentication, phishing is a common attack vector. Baseline security hardening, that's where you leverage your CIS benchmarks. They've got, you can essentially buy baseline you know, Linux images, etc., to deploy in your DevOps pipeline or Amazon machine images. Whitelisting, antivirus isn't really that great anymore, and so you know, might as well just whitelist the services that matter to you, so that anything else outside of those services are not going to be exposed. Don't expose systems to the public internet, and then do pen testing. Hire the hackers before the bad guys get you. So this is our last section. Protecting AWS workloads. We'll get into some specific screenshots and things around AWS, but here's some common elements. I think kind of the nomenclature is important. You know, definitely want to understand just the data flow and kind of high level, you know, level 0 architecture. Some common elements are, as you've probably seen before, if you use AWS, you got your VPCs, your EC2, which you talked about. The interesting one is I'll talk about at the end is AWS ECS. This is your serverless compute engines. This is becoming a lot more popular, where you're shifting really the responsibility of the patching. We talked about how important patching is and how important kind of vulnerability management is. Why not just shift it over to AWS? And you can do that by having serverless compute engines. And one of the technologies that they use is ECS, or Fargate is the actual serverless environment that they use, or Lambda. So, you know, definitely look into that as you're looking into some of your strategy. If you can't figure out how to do your own patching, maybe you can figure out how to build your environment so that you're using serverless computing. This is just showing there's a translation between AWS and GCP. They're all the same, same type of stuff, just sometimes named a little bit differently. And if you're ever just trying to discover, you know, whoever you're auditing has out there, just have them open up the console and kind of go through and have them, you know, figure out, have them let you know which services they're using. And it's all kind of a pretty easy, simple to view UI for this. So I'd always recommend kind of sitting down with your whoever you're working with and just asking them, what are you guys using? Where are the risk points? All of these types of services come with risk points. The most common one that we'll be looking at during audits is just your all these different security services. So especially with IAM and access control. So I'm going to go through a few just example domains. You know, so the governance aspect of it, that doesn't really change with a cloud environment. You know, the domains are really broken up between governance and technical. And the governance is there's some considerations there that I'm going to go through each, you know, the governance piece of it. And then there's the technical considerations if you want to really break this up into more, you know, less complex kind of terms. So the governance side, the best practice is, you know the roles and responsibilities. CEO, set the culture. If anybody wants to know what the CISO's job is, there's a great, and I'll share this slide deck out, but with the link out to the Cso Mind Map. It's awesome. It's sometimes it's confusing. What does the CISO do? And this mind map, which I have a screenshot of over here, just lists out all of the different functions. you can use that to do a gap assessment against if you don't have these roles and responsibilities lined up in your organization. It's not always one person, but the CISO's job is to make sure that all of these functions are accounted for within a company. You got the CIO kind of working through sanctioned versus unsanctioned IT. The CFO, CEO, it's not just about the budget. You know, it's a collaboration. They got to understand that it's not just an expense piece to do these security programs. It's a risk reward thing that we got to be aligned and speak the language of the CFO when we're coming up with issues. Legal, include legal in your contract reviews. Don't expect you know, information security has to be involved, include information security, but you have to tell legal that as they're seeing contracts come across the table and there's a bunch of information security clauses, that has to be sent over to Infosec to kind of review if you can really meet those commitments. And then for your chief audit executives, especially with, you know, when we're talking to the IA, is make sure you've got some automated testing programs in your basically overall audit program. So that's the governance. We'll get into some other governance areas around different shared responsibility matrix. I showed you at a high level of AWS's shared responsibilities. Most of these AWS, GCP, they all have very detailed ownership. So here's PCI as an example. If you want to put PCI workloads in AWS, they actually regurgitate the standards and they say, here's what AWS is responsible, here's the client responsible, and if it's a shared responsibility, they actually go through the summary. So if you're ever reviewing, doing your due diligence, I always recommend going to these matrices to see how you guys are stacking up against the expectations of that cloud service provider. And they do it for NIST and others as well. Don't go it alone. Other governance pieces of this, we talked about just kind of disclosures before, signing off on BAAs. You go into AWS Artifact, it's a service within AWS. You just go in there and as an auditor, make sure that these things are signed. It's a click of a button. Unfortunately, AWS doesn't really allow you to change much, but you still have to make sure that you're notifying them that they're holding sensitive or regulated data, so that way, if there is some type of issue on the AWS side, they know how to notify you properly in the event that there's an issue with that type of data. Other governance, just figure out what you're monitoring against. There's tons of tools out there. There's native tools as well. AWS Inspector, Config, GuardDuty. GuardDuty is an interesting one that kind of just monitors your environment for vulnerabilities natively. Macy looks at kind of a data governance piece. It scans all your buckets uses AI to figure out if that data might be sensitive, especially when you get in the unstructured type data. And then Secrets Manager. So Secrets is a big part of all these APIs that are out there and keys that we're using. Might as well use a mechanism to rotate those and manage who has access to them. So technical areas, can't mention CIS benchmarks enough. I mentioned serverless computing. So one of the CIS's benchmarks is making sure that no security groups are allowed from basically public internet. And so, you know, here's an example setting here that shows that you're denying all protocols. Even better, especially when you get into some of the sensitive protocols like port 22 and those types of things, you can essentially go to a model where you're not even having to use SSH. You're basically not allowing any ingress outside of I mean, basically, you're not allowing anybody to go outside the console. So you have to log into the AWS console, and then you connect into your infrastructure environment through that console versus some of those, you know, back-end tool sets, like I mentioned earlier. They're usually where the risk is. If you're just connecting to these systems from your computer using tokens on your computer or certs on your computer, that increases the attack surface. So might as well keep it tight and keep it neat and just going through what's called Systems Manager in AWS. Asset management is a big one. We talked about that earlier in the presentation. here's some tools, like I mentioned, Macy, and then S3, there's a way to manage the life cycle and retention for your particular data that you're storing in these S3 buckets. So the tools are there. It's just a matter of, are you using them or not? Access control, there's all sorts of commands you can run, but AWS has a nice report that helps you review access. Go to the credentials report, just download it. There's lots of different information on there. It's one thing to say, ask the admin, hey, how do you manage access? Just go to the credentials report and you can see exactly how they're doing it. Change control, there's things within, this isn't really AWS specific, but there's branch protection settings that within source code that you can put up, whether it's using GitHub or Bitbucket or some other source code repositories, to enforce the control requirements. We have a lot of clients that, if you guys are familiar with test and change control, we actually only look at that as an automated control, because if you set up your pipeline to force these changes to go through your controls, you don't really have to do a lot of sampling over a period of time. You're really just looking at, has those pipelines changed? So you're really looking at the pipeline change versus the actual code changes, because code can't get into production without going through things like security testing and vulnerability testing and approvals. So here's an example in GitHub that requires a review. So if it requires a review, there's really no sense in sampling, because as long as this is checked, because it can't go in, literally. Incident management, there's integration with CloudTrail, CloudWatch. These are all terms. I don't expect you guys to really take this away on this presentation, but definitely when these are sent out, leverage some of these things. These are common terminology when you're talking to these cloud service providers or anybody using AWS for workloads. BCP DR, ask where your AWS region is in. The most common one is AWS US East. That's because that's where all their beta products come out, and so they have a little bit more services in that region. But if resiliency and redundancy is important, make sure that within that region you have what's called multiple availability zones enabled within RDS, which is a database. And if you have multiple availability zones, that reduces the risk that if one data center goes down in that east region, that you've got resiliency within other availability zones. But then if you decide that, okay, I'm not only concerned about that region, I want to make sure that if that whole region goes down, you've got multiple regions, and it's really easy in this environment to spin up a entirely new set of services from AWS US East, which is in Virginia, to US West out on the West Coast. It's pretty easy to do that. You have, there's a little cost impact. You got to have that live, but it's from a pragmatic standpoint, once that's set up, it's fairly straightforward. And then you've got your normal terms, business impact assessments, data transferability. That's when you got to look into the rules. So if you're having multiple regions, make sure you know what you can do or cannot do. And then RPO, RTO definitions. So the transferability is interesting because you can actually have an app that's running all your EU customers in AWS EU regions versus US. So there, that is a possibility if there's issues with that. And that is all I have. I wanted to leave a little bit of time for questions, and I know we're about done from I think we got our time allocation for the CPE, but anybody have any questions or any other comments you feel like I might have missed today? Okay. I know 3 hours is a long time, so I appreciate you guys and thank you for the participation throughout.